Hello everyone. In this second video of mechatronics, we're going to look at implementing a code directly into Arduino. Remember the last video I talked about the online software, right, or simulator called Wokwi. You could make your circuit virtually, you could write your code, you can upload it and see the result. But nothing works like reality. So here I decided to do a simple code here and make a simple red LED blink and explain everything about it. And yeah, I know if you know mechatronics very well, this is very, very boring and simple for you. But I want to start from simple topics and then build up. So here is this software called Arduino IDE, which is a free software. You can download it and install it. And it's an amazing software because it allows you to write any code that you want for Arduino and then upload it. And the good thing about it is if you go under Files and go under Examples, it has a ton of examples about all sorts of different things you can do with Arduino, starting from basics, right, and then going to, let me see if I can move this, and then doing digital circuits, and then analog circuits, and then communications, controls, sensors, displays, and so on, strings, lots of things, Ethernet, LCD, stepper motors, and lots of things. And my goal is to go through lots of these things and run them with Arduino. So I have this box of Arduino kits, and there are lots of components I have, and I want to show you how to run each and every one of them, at least the ones that are the most common and used ones. So here I have a simple breadboard, as you can see. Let me zoom. So I have a simple breadboard. I have one resistor. I have the LED that is blinking, and I have my simple Arduino Uno. I connect it to the ground with black wire and with the red to pin digital pin 9, and I'm sending the signal on and off to make this LED blink. Okay, so it's nothing really complicated here, and this is the simple code for it. So you see I define my LED pin. LED pin is pin number 9. I call it LED, or you don't like, call it LED pin. And then here, let's call it LED pin. And then what you need to do is go ahead and do your setup. So setup is the part, as I said, the part of the code that you do once, and loop is the part that you do over and over. So in the setup, all I do is I define my pin LED to be an output. It's because on Arduino, if you look at it, there are a bunch of digital pins here on the top row. Let me see if I can show you. Now this does not have an amazing quality, this camera I'm using here, but all of these pins here, they are all digital pins, go from pin 0 all the way to pin 13. And these digital pins, you can make them to be input or output or any other thing that you want. Okay, there are other modes, we're going to talk about them later. But here I'm forcing it to be an output because I just want to send the signal out. If I want to read the push button, I make it in, and so on. So here I make it out, and then I say, hey, as long as I say so, which basically there is no time here, so this is like a while loop that goes forever. Digital write, this is writing a signal, passing a signal to an output. So say go to pin 9 and set it to high. High means go to 5 volts. Then delay for 1,000 milliseconds, wait for 1 second, then go low, go to 0 volts, then wait another 1 second and repeat. So with the frequency of basically 1 second on, 1 second off, so like 2 seconds basically, it is going to blink. And you see it goes to high and low, which means on and off. So everything is very clear. The only thing I want to explain is, one, if you look at the circuit for this, which is shown here, one thing that you need to pay attention to is that this long leg of LED, which is called the anode, this guy is the positive side, and it should be connected to the pin that sends the high voltage. And this one, the shorter leg, okay, so one leg is like this, the other is like that, it's shorter. This one is the cathode, and this is the negative side, and so you connect it to the ground in this case. Okay, now you might say this resistor that you have, right? This resistor, how much should that resistor be? How do I calculate the value of the resistor that I need in this circuit, this one? How much? If you look at most of the basic sketches for Arduino, you see this guy is 220 ohms. And you might wonder, why is it 220 out of everything else? Well, it's very simple circuit, so it's a simple circuit here. And the reason to add this is to limit the current that is passing through this LED, okay? So this LED has a forward current, that the forward current that you want in this LED without burning it is about 15 milliamps. Okay, it's typically between 10 to 20 milliamps, so let's say it's about 15 milliamps roughly. And then there is a voltage above which the LED is going to turn on and off. So that voltage for this LED is about 2 volts. Okay, so the voltage that you pass to it, the forward voltage you pass to the LED, should be bigger than 2 volts for it to even turn on. Okay, when we'll talk about the diodes, we'll talk about this. Okay, so LED is a light emitting diode. It's a diode, and diodes, especially this one, needs at least some minimum voltage in order to let the voltage pass, the current pass. That is like 2. So basically you have your power source, and for Arduino Uno this is about 5 volts. Okay, so you have a 5 here from the Arduino. It comes to the LED, and this LED at least needs 2 volts to let it pass, and the current that is passing through the LED should be not far away from 15 milliamps. If it's much less, you're not going to see much of light coming out. If it's much bigger, you're going to burn it. So with a simple Kirchhoff voltage law, you can see that the amount of resistance that you need to add to this circuit to limit it, this R, should be 5 minus 2 divided by 15 milliamps. Okay? So this is going to be about 200 ohms. And the closest resistor that you have typically to a 200 is 220. So if you plug in 220 here, and this is going to be the current, then your current is going to be a little bit below 15 amps. It's going to be like 14 milliamps or something, which is still good. As I said, this current is typically somewhere between 10 to 20 milliamps. This is the current that you want to pass through LED without burning it. And this forward LED voltage is typically between 1.8 and 2.2 volts. So here I'm using the average of the numbers. Okay, so that's the forward voltage of the LED or the diode. So something around 200 is good. Now, if your LED is a different LED, the numbers you have to read are these. You have to see how much is your forward voltage of the LED, how much is the current that the LED needs, and make sure that your power source is giving out how much voltage. Okay, if you change this board and use another board that is sending out the 3.3 volts or something, then you might need to change your resistor. But basically that's how you calculate your resistor, and that is what we did over here. If you look, that is this resistor here, which is 220, and you see that my simple sketch or simple program in Arduino IDE is working fine. So that was a very, very simple thing with proper explanations, and I'll explain more in future videos. Thank you so much, and I'll see you in the next lecture.